Okay, here we are with NTI 29. This will be our notes over the kite. Springtime, so time to fly a kite. A kite is a quadrilateral. All the angles are going to add up to 360. It's quadrilateral where exactly two pair of consecutive sides are congruent. So these two consecutive sides are congruent. These two consecutive sides are congruent. Okay, two pair of consecutive congruent sides. One pair of opposite angles are congruent. The opposite angles that are congruent, angle ABC and angle ADC, are going to be the angles that join non-congruent sides. Okay, so the angles that join your non-congruent sides are the congruent angles. Your diagonals are perpendicular. Diagonals are perpendicular. Now, there are some extra little things that come into play, and that all comes from the fact that the diagonal that connects the vertices that are in between the congruent sides, that diagonal actually works as a line of symmetry. So what happens as a result of that is bisects this angle and it bisects this angle. Okay, so everything above the AC is going to be congruent to everything below AC. Okay, it's a line of symmetry. So if we're talking about triangles, triangle ABC is going to be congruent to triangle ADC. We have congruent triangles there. And we can get that by side, side, side. Okay, two triangles are congruent. So also, this line of symmetry is going to bisect this diagonal. Okay, this is the perpendicular bisector of BD. So we get some things going on there. It's probably easier if you think about the triangles that make up your kite. So you've got triangle ABD, that's an isosceles triangle. These two angles are going to be congruent. So angle ABE is what I'm talking about there, and angle ADE, okay, just that part. Those are the base angles of that isosceles triangle. And then you have an isosceles triangle that is BCD. Base angles of that triangle are congruent. So angle CBE, this part, is congruent to angle CDE. Okay, two isosceles triangles. We also have four right triangles. ABE is a right triangle. ADE is a right triangle. Those two right triangles are congruent. We have right triangle BCE and right triangle DCE. Those two right triangles are congruent. So with our angles, we're going to have some congruencies going on. All of that will make doing some of your problems a little bit easier if you keep some of those things in mind. Okay, on our first problem, we're going to keep in mind all four angles add to equal 360. This is congruent to this. This is congruent to this. The angles that connect the non-congruent sides are congruent. And those are the angles they want us to find. So if you remember, in an isosceles triangle, If they gave us the vertex angle, we did 180 minus the vertex angle, and then we divided by 2 to get each base angle. Somewhat similar here. We're going to do 360 minus 85 minus 43. Okay, so I'm going to use my calculator for this. So 360 minus 85 minus 43. So 232. That's what these two angles have to add to equal. But because they're congruent, I'm going to take that and divide it by 2. 116. That's what each of those angles must be. Okay, so kind of similar to our isosceles triangle problem. Okay, I'm going to go ahead and do number 2 with you because it's somewhat similar. All the angles have to, or it's not similar, that's what I should say. All the angles have to add to equal 360. Okay, now on this, I really wish they would have marked this. I hate to have to guess which sides are congruent. So we're saying that these two sides are congruent, these two sides are congruent. Hopefully that's obvious. The angles that join the non-congruent sides are your congruent angles. So the measure of angle J is 82 degrees. To get angle K, we're going to do 360 minus everything we know. So 360 minus 82 minus another 82 minus 71. That will give us our angle K. So 360 minus 82 minus 82 minus 71. 125. Okay, hopefully everybody is good up to that point. Now, they throw the diagonals in at us. The key on this is to remember that your diagonals are perpendicular. So we're going to have right triangles. Notice they're giving us a partial angle here. Okay, this is, diagonals are perpendicular, so we've got a right angle there. They want to know the measure of angle PTQ. Oh, well, I just put that there. That's 90. That was easy enough. Okay, measure of angle PQT. PQT. Hopefully you remember, in a right triangle, the two acute angles have to add to equal 90. Okay? Because remember, all three angles in a triangle add to equal 180. 180 minus 90 is 90. These two have to add to equal 90. So the easiest calculation would be to do 90 minus 37. Have to borrow, so that's 10. That'll make that a 3. Remember, that's an 8 now because I borrowed from it. Probably should actually do that. So that makes that 53. Okay. Okay. So this angle is 53 degrees. It's nice to put it on your picture, kind of help you out a little bit. Okay, then they want to know the measure of angle QRT. QRT, this angle. Easy thing is, remember, this is a line of reflection. This angle's in the same as this, or this is an isosceles triangle. Base angles are congruent. That's the same as angle QPT. So that's 37 degrees. Okay. Angle 4. I really like to have these marked. It just really helps bring that out, make it clear. Diagonals are perpendicular. Okay, this is your line of symmetry. This angle right here is 59 degrees. Okay, this bisects, okay, the two angles. First thing they want to know is GDE. GDE, that whole angle. So to get GDE, I had to realize that, yes, this was bisecting that angle. So what's 59 plus 59? 50 plus 50 is 100. 9 plus 9 is 18. So this is 118. DEH. DEH, this angle. So we want to fall back to, we've got a right triangle. The two acute angles have to add up to 90. So 90 minus 59 is going to be 31. DGH, well, that's the reflection of that, or the base angles of this isosceles triangle. However you want to think of that, those are the same. So that is 31 degrees. Okay, let's come down. Now they're going to hit us kind of with everything. And I'll be honest, basically, I just like to work on my picture and look at everything. Angle 3, that's simple. That's 90 degrees. I can knock that out quick and easy. Again, I really like to have my tick marks on there. This is my line of symmetry. So this guy is bisecting the angles. Quick and easy. Angle 7, that's going to be 52 degrees. Okay. Now, operating within a right triangle. If this is 52 degrees, let's go ahead and do this. 90 minus 52 is going to be 38. So angle 5 is 38 degrees. Angle 5 is 38 degrees. Line symmetry, jump over here. That means angle 6 has to be 38 degrees as well. Angle 4 has to be the same as this, so angle 4 is 65 degrees. Okay, now again, operating within my right triangle. If angle 4 is 65, 90 minus 65 is going to be 25. So angle 2 is 25 degrees. Angle 1, this is where my angle gets bisected. That is 25 degrees as well. Okay? Seemed like a lot to do, but boiled down, not much. Okay, number 6, basically the same thing. I want you guys to try that on your own. Put your answers in the Google form. Make sure that you are good. Now, switching gears, we're looking at segment lengths. Okay, we were looking at angle measures. We're now looking at segment lengths here. They tell us that WX is 14. WX is 14. WR right here, 8. They want us to find RZ. Okay, this is what they want us to find, but I know that this is bisecting this, so this is the same thing. Okay, so I've got a right triangle. My hypotenuse is 14. Doing Pythagorean theorem. So a squared plus b squared equals c squared. So I'm going to do x squared plus 8 squared equals 14 squared. When I saw this for my x squared, x squared is equal to 14 squared minus 8 squared. I'm going to put that in the calculator. 14 squared minus 8 squared. 132. So x squared equals 132. To undo the square, the inverse of square, remember, is the square root. I have to take the square root of both sides. So on my calculator, square root on your phones, if you turn your phone sideways, should give you a scientific calculator. So I'm going to take the square root of 132. We're going to round to 1 decimal place. So it's 11. After my decimal, I've got, oops, let me pull this down a little bit, 11.48. My 8 is a 5 or bigger, so I round this up. So it's 11.5. X is approximately 11.5. Okay, for number 8, AC, that's my whole diagonal. Okay, again, let's mark this. This is my bisecting diagonal. Okay, what's on one, this is all the same as this. So AC, if I take half of 38, what is half of 38? Anybody know that? We only want to label, let's see, I'm doing ED 41, I want to find CD. So I'm going to label the bottom half. So 19, and this is 41. Okay, I took half of 38, gave me 19, DE is 41. Got a right triangle. This time I'm trying to find my hypotenuse. So I'm going to do 19 squared plus, 41 squared equals x squared. Okay, don't have to do any solving this time. So 19 squared plus 41 squared, 2042 equals x squared. Okay, again, square root both sides. It's always good if you show me what you get here. That way, if there is a mistake, it makes it a lot easier for me to figure out exactly what you were doing wrong. So square root 2042. Okay, again, what's behind my first decimal is a 5 or bigger, so I'm going to round up. So 45.2. So x is approximately 45.2. Okay, so hopefully everybody is good with those Pythagorean theorem problems. So on the back, I want you to try 9 and 10. Make sure, because when you put those in the form, I'm going to have your answers to 1 decimal place. So round to 1 decimal place. If the second number in the decimal position is a 5 or bigger, round up. If it is less than a 5, you're going to round down. Just chop it off, okay? So hopefully we don't have rounding issues on that. All right, looking at number 11. Stepping into algebra. So we kind of shift gears here. Okay, again, this is one that I think is kind of ambiguous. These are the angles in between the non-congruent sides. Just set them equal to each other. Okay, those are the congruent angles. As always, I like my maximum number of x's on the left. So 13x minus 32 equals 7x plus 22. Subtract 7x from both sides. So we get 6x minus 32 equals 22. Add 32 to both sides. So you get 6x equals 54. Divide by 6. X equals 9. Problem asked for x, so we are done there. Okay. For number 12, basically the same thing. I want you to try that one on your own. Okay, number 13, slightly different on this one. These are my congruent angles. This angle is 109. Okay, 109 degrees. All four angles add to equal 360. Now, actually what I would do on this, because I like to avoid large numbers, I would do 360 minus 109 minus 109. So 360 minus 109 minus 109. I get 142. So what do I know? I know these two angles have to add to equal 142, okay? Another option is you could just add everything up, set it equal to 360. Doing it this way, you get to work with some smaller numbers, okay? I go ahead and combine my like terms. So 5x plus 3x, that gives us 8x. And then I've got a positive 14 and a positive 8. So 14 plus 8 is going to give me 22. And remember we said these had to add to be 142. So that's equal to 142. Subtract 22 from both sides. So we get 8x equals 120. Divide by 8. And then x equals 120 divided by 8. 8 goes into 12 one time, 45. So 8 divided by 40 is 5. That's what I was trying to say there. X equals 15. Solve for x. Boom, we are done. Okay. Let's look at number 14 together. Okay, on this one, bringing in the diagonals, this is a right triangle. So what do we know about these two angles? It's just the acute angles of a right triangle. These guys have to add to equal 90. Combine like terms, set them equal to 90. So 9x plus 23x is going to give us 32x. We got a positive 1 and a negative 7. That's a negative 6. Okay? The two acute angles add to equal 90 in a right triangle. Okay? So really, this is a right triangle problem. The only thing we have to know about a kite is the diagonals are perpendicular. Add 6 to both sides. 32 is equal to 96. Divide by 3. 32x, divide by 32. Don't know what's wrong with me there. Okay, so 96 divided by 32 is 3. Okay, on this one, they want us to find the measure of angle STV. STV, that's this angle. It's the base angle of this isosceles triangle, which is congruent to this. So we're substituting into 9x plus 1. So 9 times 3 plus 1. So 3 times 9 is 27, 28. So the measure of an angle STV is going to be equal to 28 degrees. Okay. on number 15. This diagonal is the one that does the bisecting. This angle is congruent to this angle. Set those equals, solve to x, solve for x. Want you to finish that one. Check that on the Google form. On this one, this is, make sure you substitute in. Don't forget about that. This is your diagonal that's doing the bisecting. So you know this angle is congruent to this angle. So you can just plop that up there. These are the acute angles of a right triangle. They add to equal 90. Okay, so that's your setup. They add to equal 90. It's a right triangle. Okay, solve for x. Make sure you substitute in to find measure of angle in QP. Measure of angle in QP. Do that one on your own. Use the Google form to check that. Okay, so check those on the Google form. That will be your NTI for tomorrow or the next day. And then we're going to basically do a review over quadrilaterals, a quiz over all the quadrilaterals. We'll have one more week. We're going to look at some special right triangles. And that's it, guys. Take care. Peace out.